Hello, the lovely A-levels. This is a walk through the entire component 1 mock paper. I've obviously done question 7 already in the other video, but this one is now starting from the beginning, component 1, and that was the year 2019 if you wanted to look it up. I will at that point have uploaded the mark scheme to go with it, but now I'm just going to work through it gradually as we go through this. So initially it's a calculation exercise. If you were to have this printed, you would be measuring 1.1-ish centimetres, 1.2, possibly just 1.0 centimetres. I have gone with whatever you have told me you've measured, because if you zoom in on your iPad screens, and that's absolutely fine. If you're telling me you've measured 3.5 centimetres, that is fine, as long as you do the calculation with it correctly afterwards. I've been looking for 2 different things. Firstly, that you will have the equation, the image equals actual times magnification, which means you need to rearrange that, and the actual has to be divided by magnification. So I'm looking for somewhere in your calculation a divided by 1,000. Plus, I'm looking for you to rearrange the numbers in a way that you're getting to micrometers correctly. If you're starting with 1.1 centimeters, the first thing you need to do immediately change it to millimeters. It makes your life so much easier later on. So 11 millimeters. Then 11 millimeters divided by 1,000, small number, divided by 1,000. However, you will then need to times it by 1,000 again to get to your micrometers. And funny enough, you are getting, hold on a second, you are getting to the 10, 11, 12 micrometers here in your final marks. So that's what I was looking for there. Right, question II. 2 reasons for why yeast would be classified as eukaryotic. Yes, thank you. I need to have a nucleus, a distinct nucleus that is membrane bound, but also other organelles that are membrane bound, so mitochondria or chloroplasts, or you will speak about the large ribosomes, not the S70 that you'd find in prokaryotes. You are needing to have the bigger ones, the 80S ribosomes. You need to be specific if you are speaking ribosomes. Right, next bit here, when it's asking you about the yeast discussion in the population. There are 2 bits that I want to highlight to you before we move any further, because it's going to answer something for you later on in that question. If you have yeast and you have it anaerobically, what is produced when it's doing anaerobic respiration? If you're clicking in, hold on a second, that has to be ethanol, that is wine brewing, beer brewing, whatever you're brewing here, then you're in the right direction. So you're starting with yeast, maybe some dry yeast granules or something. You're going through the phases, eventually reaching that here. Let's go through all the keywords and ideas. Yeast, you can talk about in terms of hours, you can talk about in terms of days. Much shorter, much longer is actually not really meaningful if you're talking about yeast in a fermenter setting, because we're talking about larger volumes involved as well there. Right, represented by E, that is the carrying capacity. That is the maximum you should be able to reach. You overshoot a little, go under a little bit, while death and birth rates kind of fluctuate around that value. So for now, hours and days, carrying capacity, I can't use the word maximum here. So phases A, B, and D. First step is identify, which actually you did pretty well. You really did well. So we've got for A, we've got the lag phase, for B, the log or exponential phase, and for D, the stationary phase. When it's around carrying capacity, it's called the stationary phase. However, the bits where many of you failed to get that marked, explain what is happening to the yeast population. What is happening to the yeast population? In A, you need to be specific. Either use the word reproduction in there somewhere, that it is not yet reproducing. Not yet reproducing. However, we have got growth 1, synthesis, growth 2. Maybe if it was dried yeast powder, a phase of rehydrating as well. So not yet reproducing would need to be there. In the log or exponential phase, you will need to speak of birth rates and death rates, and the birth rate being far higher than the death rate, therefore the increase in population. And for D, the balance of birth and death rate in that stationary phase. So as a mark scheme, it looks like this. Initially, rehydration or synthesis of proteins, enzymes, no or slow rate of reproduction. That one was done much better with a higher rate of reproduction than actually the death rate. And the third one to say that actually those balances are those factors are balanced. So we've got no further increase. It's increased, but now there's no further increase. And here comes the question that was really done not quite well. For 1 mark for saying that eventually at the end of D, that you would get a decrease. That was done well. However, it wasn't linked to ethanol production. Nobody that I've marked so far. I'm not yet through with the entire lot, so if I've missed you out, I do apologise. So that one would have had to be linked back to what you've had as the scenario. It's yeast and it's anaerobic. This last question here, actually no, it's not last, it's last on this page. First part, identify the phases. So literally give me the letters. What phases out of A, B, C, and D, either 2 or 3, because it's a plural. Identify the phases which you would expect sexual reproduction of yeast cells to be occurring. So careful, not just binary fission, not just cell division, which you would get plenty of in B, but you're talking about sexual reproduction when yeast is flicking over to thinking, right, we're doing well now, we're in a stationary phase or close to a stationary phase, so we're actually talking about C and D as those phases, where it's switching over to saying, hold on a second now, we need sexual reproduction to make more genetic variation. Yeast will, while it's thriving and actually it's got everything, will not go to sexual reproduction. It will stay in simple cloning phase, in binary fission, just like a bacteria, just split it all up, mitosis style. So explain why sexual reproduction would be an advantage. So first thing I'm expecting to see there is the genetic variation. And also, if yeast produces spores, these ones are drought resistant, so that's helping with the spread of yeast further on once it is, hold on a second, that was the toxic waste and ethanol one. Here you go, genetic variation and the survival of spores in dry conditions, so that wind could basically blow them everywhere and anywhere. Right, we have not yet finished. There was a bit of maths coming up. The snail situation. That maths was actually done pretty well, I have to say. It is a question of rearranging this equation and just putting the numbers in. It sounds so simple, but so much can go wrong because you need to rearrange it in a way that you've got what's at the bottom goes at the top and so on. So what is it that you're doing that you need to calculate? The population of snails. Okay, so you want to rearrange it according to P. Your P is at the bottom of your equation. So it's a question of how do you swap them all out, and be careful with that, because I've got those who've messed it up in the phase where you're rearranging the equation. There are 2 ways of doing it. Option 1 is you rearrange the letters. Option 2, which some of you that are struggling with that might actually prefer, I don't, my maths is steady, but some of you might prefer putting the numbers instead straight in, that you can calculate and say, hold on a second, that is my missing value that I've got and the rest is all numbers. That might help you. As mark scheme, it looks like this. So if I've seen that you have substituted the right way, so it's a rearranging it and then substituting the numbers in the right place. If you then did a little calculator mishap and you didn't get to the right number, fair enough, but I need to have the rearranging the equation, substitute the numbers the right way around, or at least do the substitution like this, where you can say, okay, I've put the right numbers in the right places, but I just didn't do the rearranging of the equation yet. So you can substitute the numbers right into it. If you're mathematically not steady, you might want to do that just to give yourself 1 mark in case you were to run out of time and you just want to get through those questions quick. Right, last question of question 1. Suggest 2 assumptions that must be made when you're using this technique, the capture, mark, recapture technique. 2 assumptions you need to make, and you did this one very, very well. The first one that most people have thought of was the, hold on a second, will the mark increase the number of predators eating them because they've become far less conspicuous, or will they no longer want to, will they be heavier due to the mark, so the mark has to not affect the snail. The second one seems to have been a bit harder to get. Will my snail mingle with the normal population the same way? Will they have enough time to mingle before being recaptured? As a mark scheme, it actually lets me, I just need to pick 2 of those, or you need to get 2 of those. Oh, that one was done pretty well as well, actually, the births or deaths rate, that was done pretty well. So that in that time span between marking your snails and capturing your snails, let's say your time span was 3 years. snails have long died and been replaced by baby snails by then, or grandchildren snails by then. So is your time span in a way that births and deaths have not really changed the population significantly? No significant snails have come in from the other garden or have emigrated to the other garden situation. The markings, see, you've done pretty well as a cohort. The distribution one, nobody has really considered that, but that would have been a mark you could have gotten then. And the whole idea that the marking itself, that was done pretty decently as well. Okay, so that was question 1, and I shall hopefully fight my way through all those questions before long.